Hey YouTube, welcome back. Today we're starting a new series. Today we are talking about the consistent hashing, and we design system. We design a consistent hashing system. So, previous video we talked about the horizontal scaling of the database, and we talked about the resharding problem. And we said one of the way to solve the resharding problem is using consistent hashing. And basically, any server that want to achieve the horizontal scaling, it is important to distribute request data effectively and efficiently, and evenly across the servers. So consistent hashing is a commonly used technique to achieve this goal. But first, let's take an in-depth look at the actual problem, like why we need a consistent hashing. So today we'll try to talk about what the rehashing problem is. So let's assume that we have these servers, okay, and with all these servers, let's just create. No, let just leave it there. So with these servers, let's just say that we have key, and the key of each one is 0, and this 1, and this 2, and this oh sorry, and this 3, oh no, 4, 4, 5, 6, and 7. Yeah. So basically, let's assume that, let's just make the space quite bigger, and I guess we need to make it wider. And let's just add, no. Okay, so right now we have the servers, the key for each servers, and the hash key value of each server. And let's say that we are going to hash the servers, and we mod it by 4, because we have 4 servers. Okay, let's say that we have only 4 servers, and each server takes more than 1 key. So we are saying that we mod it by 4, and let's just add here their value. So first one, it will be it will be 1, and this one, it will be 0, and this one, oh no, it will be 0, and this one, it will be 2, this one, it will be 0 again, and in this one it will be 1, and in this one it will be 3, and last you have 2, 2 and 3. So basically, right now our hashing function works perfectly fine. We have here the key, and we have the actual hash value, and we hash it on this on the in cache servers. We hash it on the length of, or the number of the servers that we have, and we get these values. So basically, if we have in, which is this one, in cache servers, a common way to balance the load is to the following method. I guess most of you can get it now. So the following method is that the server index will equals the hash key, which was the key, and we are modded by n, where n is the size of the server pool. So from this you can understand, like n right now is 4, and you can understand this one, like 0 is modded by this value, it will be give 1, etc, etc. So how does this look? Let's just take a pen, try to draw this one. So let's say that we have 4 servers, like this one, 1, and 2, and 3 and 4. Okay. So in the first server index 0 and 1 and 2 and 3. So server index 0 will get, I guess it will get key 1 and key 3, right? Yeah, it will take 1 and 3. And number 1 will take 0 and 4. And number 2 will take 2 and 6. And number 3 will take 5 and 7, yeah. So everything looks clean, everything looks good. I guess there is no problem. So what is the problem that I'm talking about? Like everything looks good, everything looks great. So this approach works well when the size of the server pool is fixed actually. Like don't just let these numbers fool you. So, and the data distribution is even. However, problems arise when new servers are added or existing servers are removed. For example, if the server 1 is offline, let's just change the color because I guess let's say that this server is offline. Okay, so from this one the hashing value, it will not be 4, it will be 3. Okay, so from this we will do the rehash again because it's different. So however, the problem, as I said before, arises when the server added or existing server are removed. So for example, as I did before, if server 1 goes offline, the size of the server pool becomes 3. Using the same hash function, we get the same hash value for a key, but applying a modular operation give us different server indexes because the number of the servers is used by 1. So let's just see what we're getting here. So basically we are getting, let's just try to take this one. So instead of getting 1, what we get here 0. Instead of getting 0 here, this will be 0. Instead of getting 2, it will be 1. If this getting this one will be 2, and this one will be 1, and this one will be 0, and this one will be 1, and this one will be 0. I don't know if you can recognize it, but all the server indexes changed, and we talk about that in a bit, but just give me a minute. So basically right now, let's talk about what is the new one. Server 0 used to have 1 and 3. Right now server 0 has 0. The server 0 has yeah, is hash to 0, and also it has 1, it has 5, it has 6. It's no longer have 1 and 3, and this one is offline. So let's look server 2. Server 2 has 2, 4, 6. 2 is still there, and 6 is still there, but we have 4. Oh, no, 6 is still there. Sorry for that. We have 4. And here we have 3. So 5 is not here, and we have 3. So I guess you can see most of the clients had changed their servers. So as you can show here, most keys are redistributed. Not just the ones that originally stored in the offline server, which is 0 and 4. Okay, this all of them has been changed, most of them basically, and this means that when server 1 goes offline, most cache clients will connect to wrong servers to fetch data. This causes a storm of cache misses. Consistent hashing is effective technique to mitigate this problem and solve it. So basically, what is a problem? The clients before used to go to like the if the client's hashing function, the first client and third go to 0, and here go to and the 0 and 4 go to 1, and 2 and 6 go to 2, and 5 and 7 go to 3. However, when we take one server and only one server, you can find that most of the clients connected with the new servers, and we had a huge cache missing, which lead us to a lot of problems when it comes to scalability, and a lot of latency, and a lot of failure data, and also after all of that we will have bad user experience. So how can we solve this problem? Is we're using a consistent hashing, and this is what we're going to talk about in the next videos. So today we talk about why consistent hashing is needed, and yeah, in the next video we talk about what is consistent hashing and how the consistent hashing used to manage to solve this problem. So yeah, that's it for this video, and hope you like my content, and see you in future problems.